think we're live. Let's see. I'm gonna have to check whether the stream is active. I have some new equipment and this is still in progress, so I have not tested it out. I'm hoping to resolve it live before we start the session, but let's see if this actually works. I should have some preview of the stream. OBS says I am streaming, so that should be fine. We should also have audio. That's correct. Okay, the YouTube studio says it's live. We should be live. I don't see any messages in the chat, but I think I can just log in there and test it out. Hoping some people would join still today. We should have some viewers. I probably should invest in some external monitor as well to trace that. Where are my videos? Should be. Have some viewers. Okay, the audio is live. Monitor as well. I'm gonna type a message in the chat, see if we can see something on my overlay. This should pick up some messages, unless it doesn't work. Nope, I don't see the messages. I should think that I'm gonna keep some window open. Message in chat, see if we can see something. Okay, it's gonna just keep me distracted. I think I should just drop the window. Oh, okay, the message actually is there. That's fine. That's great then. I think we can start. Okay, hello everyone. I am Kuba and I'm a performance engineer. So today I thought we're gonna do some live chat with a bit of Q&A on Kafka and what is it, and specifically if you're a performance tester, performance engineer, how to test that. The reason I'm starting this topic is because I'm working currently on some plugin to help you load test it better and get some more accurate measurements of that. We can touch up some existing plugins. I'm going to tell you what they are good for, what not necessarily would work, and I want to focus on a specific scenario. So maybe if I just, 1 second. This is still a preparation for me, so if you guys want to ask any if you want to ask some questions, you can do it in the Q&A. So, and the chat should also work, so you should be fine. Okay, so let's start with the basics of what the Kafka is, what are the components that are important for performance test. The first thing you need for a Kafka. Let's start. We're gonna start with like the way the message follows the entire flow, right? So let's start with the first component that you need to actually send the message to Kafka. So I'm going to start a bit from the practical level. This is going to be our producer. So the producer, I'm going to name it here as a producer. The producer is the component that can send the messages down to some stream, right? Kafka is known for as a streaming broker, and I'm gonna get down here. So the producer is responsible and allows you to send some messages. We have some message here since producer, and it sends it down somewhere, right? So this is the message you formulated. You wanted to send it somewhere, and that's the main idea for the producer. Each message that the producer sends gets appended to the end of some stream, right? And this is important because the messages will always land at the end of this stream. They cannot be, say, put in the middle. They cannot be deleted, although there are some exceptions to this rule. But in typical setup, these messages will be sorted by the time they have arrived to this entity, and the entity that collects those messages I'm gonna here. The entity that collects these messages is this is called a topic, right? So essentially, I have to put text here somewhere. Okay, and this is the main form of accumulation of the messages, right? The producer sends the message to the topic, and this is done asynchronously mostly. So the producer thread and the network threads, they are mostly asynchronous. So you can just send us message and they land on a topic. And the main assumption for Kafka and for asynchronous messaging is that you no longer care about the message and what happens to it, right? As long as you have received some confirmation that message has been accepted, um, that should be enough for the application, right? So, and that's very important because it's very different from the protocols you might know, like REST or SOAP or any HTTP. When you send the message, you immediately lock your thread, and you await for any response or acknowledgement, or like for the complete transaction, right? The Kafka topics work a bit different. So this process of sending a message and receiving any response back is decoupled completely. So it's important to notice that when you send the message, it doesn't actually guarantee that the message will be processed later on or be picked up by by anyone. The only thing that you can guarantee is the delivery of your message, right? So messages land on the topic. They always land on the end of the topic, and what happens later is, yeah, we're gonna touch on that. So once the message arrives on a topic, it can be consumed, right? So there's another process. Mm, ah, there is another process which is called a consumer, and the consumer can pick up the messages from the topic, right? The thing is, and this is very important here, consumers and producers, they are not aware of each other, right? So they have no form of communication and the standards they set up. They cannot communicate with each other. The only form of communication right now is via the entity that holds the topic. We're gonna touch upon it later, right? And the consumer here can pick up any message from here based on its offset, right? So a typical setup for a consumer would be just to listen to any new and upcoming messages, right? So the consumer can effectively just move it here. The consumer can pick up the message. Let's say start from here. I think here. I wanted to make it a bit more interactive. It's going to be a bit challenging. Okay, so the consumer can start picking up the messages, let's say from here, right? And we have a few metrics that we recognize and we can measure from the consumer perspective, as well as producer perspective. First one is the topic start, right? So this is the topic start. Typically, the start is at the very beginning of the topic, but it doesn't necessarily mean that the topic start will be a message 0, right? But the first message that is in the topic is called the topic start. So I'm going to add here some marker. I'm going to add here some marker. If I can move that, should be here. So this is a topic start. And effectively, the last message that you see on a topic is called the topic end, right? So the messages will always land on the topic start. Sorry, will always land on the topic end, and the topic end will be moved. If we add a new message there, always the topic end will be moved there, right? So that's the main idea for that. If we can have anything. I see the chat here somewhere. No, I don't. Okay, so this is the main idea of the measurements, right? The consumer, if it has any delay or there were some new messages entered in the entered to the topic, the metric between the message that it had just collected or pulled and the topic end. So this metric here, I'm gonna add some metrics as well, for us to have a common understanding of those metrics. Okay, this goes here. I'm gonna probably draw some lines here. The difference between the message that the consumer had picked up and the topic end is called a consumer lag, right? This effectively means how many messages are currently pending that have not been picked up by the consumer, right? Because they are completely detached. The only thing that is blocking the pick up the message is how we actually pull the messages from the topic, right? So this is the consumer lag. And this is probably the most important metric from the consumer perspective of how many messages are still like unresolved, right? Typically, if the lag is accumulating, it means that we have some problems in processing the messages later on, or there is some problem in synchronization. But the most, say, vital metric for you to monitor would be how far the consumer is from the topic end, right? The topic start is also a movable metric, right? It's not a fixed one because unlike the protocols like, for example, MQ, the message does not disappear from the topic, right? So at least not once it's pulled. Sorry, that was my daughter. So unlike the protocols like MQ or any other queuing messages, the message does not disappear when we pull it, right? So it doesn't just disappear when we start moving. There are two, I think, conditions that can make these messages disappear, like on the standard configuration. The first one, the first condition is the retention time. So you can set up here if you have retention of the messages, let's say 1 day or whatever your capacity of the topic is. After certain time, these will just disappear, right? So, and then the topic start is going to be moved to the first message that is still there on the topic, right? So you can see here, this goes here. And once it's gone, it is gone, right? So the message would not be able to retrieve. But typically, the retention time is set up and configured for you to make sure that you can still reprocess these messages in case of some failover or some disaster mechanism, disaster event from from any external topic, right? Say consumers would die, they would not be able to process it for a while. You have some external dependency, I don't know, some patching events. You still want to accumulate those messages somewhere for later processing, right? So internally, the messages, at least until now, they were stored on a disk. I know that there's been some changes right now and proposals for completely diskless Kafka, but still most implementations rely on this reliability and persistence on a disk. when you store those messages, right? So the consumer can pull the messages, producer pushes them to the topic. That's the main idea, and the communication between the producer and consumer. Very important to remember that they are not communicating with each other. I've read some implementations that there's some external database or some other components on REST service that for especially for was it the partitioning strategy, that producer can detect, or the consumer reports its lag, and then producer, based on the lag volumes, can reroute some more messages to the partitions that have the lesser lag. But normally these are completely detached, and the consumer and producers, they are separate entities, right? So let's focus on the consumer right now for a bit. The consumer can pull as many messages as it wants, right? So it doesn't take the messages one by one, although libRD Kafka does it actually underneath. So any message would actually be copied to the consumer thread. But to the user, on the user space, the consumer pulls as many messages as it wants, right? So the polling interval it can do the polling of the messages of how many wants. There are three conditions that can be met for the consumer to stop the message, stop the message polling. First one is number of messages. First one is number of messages. There is also size of messages. And the last one is max polling time. These are all configurations that you can specify in the consumer setup. But as soon as you meet one of the criteria for one of the thresholds for this, you can the consumer will stop polling and will return the messages for the processing, right? So the consumer takes this message here, or it can take 4 at once or 5 at once, and then the consumer lag would be decreased, right? So this is where this operation starts, and you can consumer lag would effectively be 0, right? If it doesn't poll here. Very important thing, because the consumer can pull from any place it wants, but also there's a risk of reprocessing some of the messages, right? This is where, like, to avoid any duplicate messages or duplicate processing, consumer and the Kafka broker, which I'm going to talk about later, they store the offset of your consumer group. So this the new term we're also going to talk about later. The consumer, whenever it polls the message, it leaves a marker. Let's call it a marker, but this is actually a storage of the offset on the broker to where was the last message it had pulled, right? So let's leave a marker here. Let's leave a message. Let's say the consumer, it started here, right? And this effectively is the offset, right? Offset for this particular consumer, right? This consumer, this was the last message it had picked. And then later, when the consumer either reconnects, or I don't know, there is a new connection, or there might be a new consumer coming in to pick the message, the broker remembers the offset that the consumer had persisted, and any other consumer can just resume the work that this consumer had left, right? So think of it as I don't know, Jira ticket. Someone had left, and this is what I have done. This is what checklist, and this was the last task I had picked up, right? The other consumer can go and gonna lose this guy here, but then there's gonna be another consumer that can just pick up here, pick up the message, and resume the work from what it left, right? So effectively the offset changes, the offset of course, and the topic end, this is your consumer lag. And once the job is done, we can just the consumer can wait for new messages or can be closed. This is totally up to the application architecture, right? So one transaction, one operation that the consumer has to do to keep this offset is a offset commit, right? So the consumer can commit this message. So it said it could pick up the message, and once that it had been processed or persisted somewhere else, the consumer can commit this message, which effectively means persistence of the offset on the Kafka block, right? So the process in the consumer, I think I'm gonna have to move this. Oh, this might be better. Um, the process of the consumer is also a bit delayed because of that, right? Unless you're using asynchronous commits, but then you have very little control over what actually and how many messages you can pick up. So the consumer can actually be a bit delayed because of those commits, right? So to achieve the most throughput and the most, say, yeah, the best throughput for your application, you want to poll as many messages as you can at once, and then process them and limit the number of commits you're doing towards the book. Sometimes it's not possible. Sometimes the messages, if they are polled in a transacted context, they have to be polled one by one. And this is where the throughput is a bit limited for each of the topic partition. So now that we know that the consumer is polling the messages, it's leaving the offset, and that we know that they can be blocked by the commits. Let's talk about the scaling of Kafka topics, right? Let's remove these objects here. Now, to make sure that the topic can be scaled, and actually one of the main mechanisms for the Kafka scalability is called a topic partitions, right? So we know that we can send messages to the topic, and that's fine. But there is also a feature which is the one of the Brazilians and scalability mechanism, the implementations for Kafka. This means then this is the implementation of topic partitions, right? So effectively, um, instead of having a single stream that we can push the messages to, Kafka allows us to I think I'm gonna have to. Kafka allows us to send the messages to various topics, topic partitions, right? This is something that allows the most throughput and the most scalability of the system. Okay, let's see if we can do it like that. And effectively, we have multiple micro topics. Let's say these are not micro topics, but these are fully fledged partitions that act as a separate entities on the brokers, right? So we can have a producer. See if I can. Okay, we can have a producer that sends the messages to various partitions and have them. Okay, so this, let's say, producer sends the message here. It can send the message here, right? And it can send the message here. This is called partitioning, right? So each of the topics acts as a separate chunk of the topic, and it just means that we can have multiple consumers also polling from the messages, right? And the thing is here, it's not a consumer actually requests for the topic for the message from the partitions. It doesn't like wait or the topic actually cannot just forward the messages itself to the consumer, right? The message goes from here, so from the partition to the certain consumer, right? And the consumers can just pull them from each of the partitions, right? So this is how the scalability of a Kafka topic works. But now this imposes a few problems in terms of resilience of the system, right? Let's just talk about how they are resolved, right? Let's say we have multiple partitions, and let's say we have a matching number of consumers. So each consumer goes is taking messages from a separate partitions, right? This entity normally, if you want to have an atomic or if you want to prevent any duplicates from your system, this entity is called a consumer group, right? So you have a group ID defined for the consumers. This effectively will be your consumer group, right? So let's also group them together. Okay, let's go backwards. This is your consumer group, and these act as cooperative as they can. So they work on each of the topic normally, and this is the best practice to have. If you want a maximum throughput, you want to have maximum a one partition per consumer, right? So that effectively each of the consumers can pull as many messages as they want. We're going to limit the number of commits. We're going to maximize the throughput that we want to have for the application, right? So this could work, and each of them would leave its own offset, right? So going to have the offset of the say of this guy here, right? This is going to be the offset it had left. Move, okay, I want to move this guy. Move. Let's say this guy had left here. I would really love to make it animated, but this animation takes a lot of stuff to a lot of time to complete. Let's say we are still moving those offsets, so we're still pulling the messages. There is some lag on each of those, right? But what about the resilience? What if we say lose this consumer, right? There can be a lot of events that can happen, that the consumer could just be lost and taken away from the group, right? And this might be a bit problematic, right, for the other consumers to pick up, because if you stop polling from the certain partition, you're gonna lose or time out the messages that have not been picked up, right? But if you have a consumer group set up, the consumers are allowed to pull the messages from a different from multiple partitions at once, right? And this is something there are two rules that are important to understand in the consumer groups. And these rules only apply to consumer groups specifically, that a single partition at a single time can be assigned only to a single consumer, right? So there cannot be a situation that at the same time the same partition will be assigned to multiple consumer groups, so the multiple consumers. There cannot be such a situation. So it's not going to work if you have this multiple consumers from the same consumer group polling from the same partition. But there can be a situation that a single consumer can consume the messages from multiple partitions, and that's okay, right? Because there is no risk then. There is no risk to lose any messages or to have a duplicate messages, right? Offsets and the commits are atomic, So there is no risk that the two consumers would pull from the same partition at the same time. The event that is enforcing that and the strategies for forcing a say balance between the consumer polling is called consumer rebalancing, right? And there are various strategies for that. The standard one is actually a reshuffling. So after rebalance, all of the consumers actually lose their access to the topics, and the topics can be reshuffled between all the other ones, right? So a consumers like this consumer is gonna get this topic. I don't know, this consumer is gonna get this topic. It is not guaranteed that the consumer after the rebalancing that the same consumer is gonna have the same topics after the rebalance, right? This is a bit chaotic, and this also is a disruptive event, the consumer rebalancing specifically. Um, but and effectively means stop the world for the entire consumer group, right? The Kafka broker has to determine which consumers can pull those messages from the topic, and has to stop everything, all the processing, to reassign the partitions, right? Um, this is something that has been improved over time, and one of those improvements was a sticky partitioner, is a sticky assigner cooperator. So, and the basic assumption for that is if we lose if we lose one consumer, all of the others that had the okay, let's do this again. Um, this guy goes here, this guy goes here, and this guy goes here. If we lose the consumer from the consumer group, instead of pulling back every single consumer back to the pool and reassign all the topics, what it tries to do, what the broker will try to do, is to just reassign the missing partitions between the consumer that had the lowest workload or has the highest response time, so responsiveness and the poll, right? So if you say like this guy had the most, or this guy was actually the busiest in the period, so to reassign the partitions to certain consumers, right? Without disrupting all the other work. So other consumers can still pull the messages from the topic, and only the consumer that had been kicked out of the queues from the partitions will lose this. And effectively, when you reintroduce some consumer or some new consumer joins the pool, right? It has the biggest chances of getting the partitions that have been assigned to the consumer that had the most partitions, right? So these events, they are very important because they are disruptive to the entire consumer group, but they're also the main backbone of the resilience setup for the Kafka, right? That's essentially it, I think. A second, let me just verify some few things with the stream. If this works or not. This should work. But let's see how well. Okay. Let's see if we can have some viewers. I'm gonna still have to set up some pause screens for these sessions. You'll have to apologize me, guys. Forgive me, guys, for my lack of preparation. I mean, this is a bit of unprepared. I'm still in the middle or in the process of perfecting these sessions and getting some more insights for you guys. I'm hoping to get some more viewers, some live viewers, but since this is still Sunday forenoon, I don't think many people would want to see or watch Kafka videos when they are tutorials, when they can have some fun with their families, right? So this might be a thing, and I'm still like in the middle of processing that. I guess the LinkedIn is a bit quiet as well. No wonder who goes into LinkedIn on Sunday morning. There might be a few people, but of course it's not the main audience, say, for us. Okay, still setting up some things. Huh. Okay. Back to the topic of Kafka, right? So you have a producer, and actually at the same time there is a producer, so you can have a multiple producers that would send the messages to all the partitions, right? We're gonna talk about the assignment to partition as well. So I think we can start right now to the assignment of the partitions. So by default, the assignment to the topic is determined by the key um, of the message, right? Each message that lands to the Kafka. Let's go with the message. So each message has a key, right? So there's a say message one, let's say, and there is some body, right? So like effectively, also you would want to, you would expect the some headers, right? So the message goes here. There are some headers as well. So let's add some text field. Let's add some text field, right? The headers would be like now, what's the return address? Where it goes? Okay, where it goes, we actually need. We actually have already, but there's some return address. So how to read that? There's some encoding, uh, uh, some timestamps, etc. Right? So you have a headers of the message, and you have the message body, right? So you have the full contents that there's some. So actually, internally, Kafka stores all of the messages in a binary format. So that's why when you see the code for any producer, you have to specify the serializer that is and the serializer to convert those messages into the binary format, right? Even if you store them as strings, so even if you have a string message, um, you have to convert those into binaries so they are then forwarded to the Kafka broker, right? So each message has also its key. This key is important because it's typical and the standard strategy. So the default configuration for Kafka producer is that it takes the hash of a key, and based on the key, the message would land on on different partitions, right? So let's say message one is going to land on topic one. Let's copy here. Message two. Message two. I'm just making things up right now, so this is not the not actually the values they're gonna have there. But message two is going to land on the topic three. If you, for example, resend a message with the same key, it is also going to land on the same partition as the previous one, right? So if you have some duplicates, they will also land on the same topic. It's very important because then this, but by default, if you have random keys, if your keys are fairly randomized, um, then you can expect even distribution between the topic partitions, right? You will not have the situation that you have more messages on one partition, and then therefore, overloading your consumer that is responsible for processing these messages. And yeah, this distribution is often very important, deterministic for your application latency overall, right? So the end-to-end latency will be affected by that. So normally you would expect even distribution of the messages, or fairly even. It doesn't have to be like exactly the same, but a fairly even distribution is expected for the Kafka messages, right? This is the default behavior of the producer. There is also another one, which is a round robin. So you can actually specify each message can specify which topic, which partition it wants to go. So you actually, in the headers of your application, in the producer record, you specify which partition ID goes, right? So this has to go through to partition 3. And regardless of the key that is specified, this would always land on the partition, on the topic partition number 3, right? Uh, Actually, I have named these, just realized I've named these topic and partitions, but I don't think that's they should be actually named as partitions. Yeah, I think I'll have to change that slightly. Just to reflect those better. Seconds. Okay, so effectively, you can also specify in your own strategy on how to distribute your messages. I've read about some implementations. Specifically, this implementation was related to different clock speeds and different hardware for each partition, for each consumer, right? The application could not guarantee a uniform hardware for each of the consumers. So effectively, some consumers were slower than the other, but there was no way to actually make sure that these consumers have received also less load than the others, right? So this is a bit of a risk. Why does it look like that? This shouldn't be. This is a bit of a risk, and I understand that the application that the developers have came up with an idea to actually store the consumer offsets and to store the lag on some database or some service, and then have the producer poll the topics with least lag on, right? So they knew then which partition to send the message to avoid any excessive lags to the system, right? So but the standard one is always, if you don't specify your partitioning strategies and you don't specify the partition in the producer record, you can expect that this will be defined by the key. And if you have duplicate keys, they will always land on the same topic, right? So that's, I think, more or less it from the perspective of the consumer groups, I guess. What else is there? Yeah, okay, that's pretty much it, I think. Yeah. So we have the producers sending messages to a certain partition. Then we have the consumer groups that are polling these messages, right? Message partitioning and allocation to certain partitions happens by default per key of the message, and this is the basics. Okay, so the entity that is holding the topics and the partitions effectively, this is called a broker, right? So we can have multiple brokers for so these are physical servers in the Kafka. So let's set the background here. Um, these brokers, they store and manage the persistence of the okay, just add some text in here. They manage the persistence of the messages and their replication, right? Like by the assumption and the say main motivation for developing Kafka was to store a highly distributed system on a commodity hardware, right? So actually the first implementations and the idea was to have a cheap replication and resilient setup on the commodity hardware, right? So we're talking about HDD drives and some lower tier hardware instead of having very expensive um, very expensive mainframe systems or some SAS drives to store the messages somewhere, right? So and to achieve that, they had to also make sure that they maintain the same resilience of the setup. And by default, we'll probably get the screen. Um, by default, these messages, the entities that are holding these messages, they are called the brokers, right? And they maintain the replication factor and storage of the topic partitions. There's some education here. Okay, so these brokers, they hold the topic partitions. But also, since they are low resilience entities, they just see if there's anything. There's no comments yet. Actually, if there's anyone listening and can say hi to the chat, I'm gonna also reply. So these brokers, they hold and manage the replication of the um, of each topic and each partition. But also they are, like, by default, they are not as resilient as some external systems. So they lack of resilience has to be also mitigated somehow, right? So typically what you have for a resilient setup, you want the Kafka system would have at least 3 brokers and at least 3 replications of the 3 replicas of each topic. So effectively, if you have a topic here, for example, topic partition, let's go with this topic partition 1. I'm gonna just select it here. Effectively, I'm gonna copy here. Let's just move it slightly down. Let's say we have a topic partition number 1. Somewhere pretty well, visual aspect at least. When you have a topic partition number 1, this is going to be stored on one of the brokers, right? So again, some entity that is holding these topics, right? Here, this is the broker 1. See, I don't like these text fields because they never align with what I want. Probably I'm using it wrong also, but the broker broker one. Well, let's say this broker has a storing the topic partition one. Damn it. Oh, I don't want that. This broker is storing the topic partition one, but also it's storing the, let's say, partition 3. Partition 3, right? And these are what's called a partition leader, right? So replication leader. So partition leader, one of those. Anyways, this effectively means that this is the first source of information for the consumers to pick the messages from. But also, if in case the broker one would die, what happens then? Let's copy this over. Once only, sorry. Let's copy this one. So the broker 2 actually may contain might contain a topic partition 1 copy and topic partition 3 copy as well, right? This is to make sure that whenever a broker dies, it, like, we can just lose the broker 1, right? Effectively, broker 2 would take over, and the Kafka brokers will have to make sure that, and your setup will have to make sure that at any given time, when you lose any broker for any given reason, this can be like the reasons can be very trivial, or they can be disastrous for your setup. But whenever they do, you need to make sure that the brokers can have can act as a replacement at any given time, right? So effectively, these brokers send out those copies of the messages to all the replicas of the topic partitions, right? So when you have a message sent to the broker, so let's say we have a producer that is producing the message. Okay, this is good enough. So the producer sends out the message, it actually gets replicated, so it goes here, but it also goes here, right? So it knows where the replicas are, and the producer is actually effectively connected to all the brokers, and it sends out these messages, or actually no, actually it does only once, but these brokers are aware of each other. So the topic partition, let's say this message goes here, right? And then it gets replicated to other broker, right? So then in case the broker 1 dies, the consumer will start consuming the messages from broker 2, right? And this piece of information, so the sending and transposing the messages between the brokers and copying them over, this is called a topic and partition replication, right? This message replication between the brokers is very important from the resilience perspective of your system, because if the messages are in the transfer in the process of replication from broker 1 and broker 2, if the transfer is not completed yet, the broker would die, then you've lost the message, right? So if you have a fully requirement of a full resilience, you want the exact once delivery of the messages. Producer would not know, like typically in the center setup, the producer would not know that it had lost the message. It would just continue. It will just continue processing the other messages, right? Not a best scenario for a resilience setup, right? So instead, what can be happening, and this is something that is there is a property on the consumer side that can determine to actually for the producer to wait for the replication to happen between the brokers, right? And this replication property is called ACK.
So the number of acknowledgements the producer expects before it stops trying to send the messages, right? Um, this is something that is very important from the resilience perspective, uh, so that you do not lose the messages, right? So the producer can actually lock itself on all the messages, like on all the brokers, until they are fully replicated, right? So, and this effectively means that the okay, I've messed up the delivery here. Um, so the producer would lock and wait until all of the messages, until between all the brokers, will be replicated, right? This is very important from the resilience perspective, so that you don't lose these messages. But also this configuration, setting up the ACKs on the larger scale, this also means greater latency from the producer perspective, right? So the producer will not send more messages, and the throughput could decrease because it awaits the replication between all the message brokers, right? So when we talk about latency, from the producer perspective, there is a network, there is a batching. We're gonna cover that also as well. But this is also a matter of replication, right? This is sometimes the most important part, because even like, for example, the broker doesn't have to die, doesn't have to go out of the from the pool to affect the producer. It's enough to have one broker overloaded. I don't know. It's maybe just the replication is not equal, not even. Maybe some producers send more messages to the partition to some partitions that are on this broker. But if the broker is overloaded, it's enough. If you have the producer locked onto all the on the full replication, it will affect your end-to-end latency, right? So the producer will not be able to send these messages as fast as you would want, or as a standard request. This is something to remember, right? Um, Quality of service. So we know that we can lose messages. We know that the actually sometimes the producer can send duplicate of the messages. There can be some situations where the producer actually would produce duplicate messages, uh, unless they use a specific configuration, right? The two implementations I know to guarantee the exactly once delivery are using a transactional scope. So, but unless you are using the XA really and the persistence of the on the database of the messages and some two-stage commits, it's not it's very expensive, because the transactions in the Kafka topics they actually mean pushing the message to the transacted topic itself. So the Kafka internally has its own internal topic. Um, um, and this topic is used by Kafka to store the transactions. Right, so it's not recommended unless you actually truly want to handle the unless you truly want to handle the resilience and the rollbacks and the whole transactional context. And also, since Kafka version 11, there is an option to send idempotent messages. This actually has some requirements. So this um, um, using idempotent configuration requires acknowledgements on all the brokers, right? So you have to fully replicate the messages on all the brokers to use this exactly once delivery, right? Otherwise, you're always at risk of either missing the messages in some disruption events, or sending the duplicates out on the topic, right? And well, the impact of the duplicate or missing messages, this is totally up to the application, right? There are systems that can handle those very well. If you, for example, want some continuous streaming of some data off, so I don't know, mm, GPS data or something like that, a missed message may not be as impactful. But if you want some more critical messages that some customer is actually actively waiting for some response back, then this might get you in trouble. Um, think that's covers it. What else I wanted to talk about? Uh-huh. What else is there? Okay, so we have consumers, we have producers, we have brokers, we have replication. What else was there to talk about? Um, this is actually, could this be it for the basics? So we have the lag. Actually, the metrics for the brokers and for the replications, they are available in the JMX. So we can talk about it later when we're going to be instrumenting the Kafka with OpenTelemetry, or just some basic monitoring. Uh, Both producer and the consumer and the broker, they have extensive list of JMX metrics you can monitor and trace, right? The one notable for the brokers and for the partitions would be the replication lag, right? This is where you know um, this is where you know that you have some problems in the replication, and this might but doesn't have to affect the resilience of your system, right? Um, okay, so uh, this is very bad timing for the stream, actually, because there is nobody here, and I get questions at that time about it. But that's good anyways, I think. What else was there? Producer. Oh, batching. So in a typical scenario, say let's say a Java client. I'm going to talk about Java client because that's the one I know the most. Also use some Golang, but that's just for some processing. Producer is in nature, at least the Kafka producer that you have from the Java client. The producer is actually asynchronous, right? So if you do a producer send message, um, just get here. Okay, this is a producer. I'm gonna get some message. Okay, so if you try to send a message to the producer, right? It basically returns immediately because producer. And this is coming from the documentation here. See the documentation. Producer send. The send method actually returns a future object. Just get. See here the send method of a. This is one of the the big problems or misunderstandings I'm seeing from people working with load testing the Kafka. So and effectively about measurements of how fast does it get to send those messages. That's very important as well. The send message is method is asynchronous, right? So it first of all does not guarantee that the message had been sent unless you have this resilience in setup. It also does not measure the actual time it took to send this and to replicate this messages within your scope. right? So this is very important to understand because I see a lot of people trying to at least get the generate some load. What they focus on is sending the message, and this is all they get, right? Effectively, if you just focus on the on sending the messages, and you want some actionable measurements from your load testing tools, you might be in the wrong place. I mean, you're missing out of all the part you could be measuring from the end user perspective, right? The end user meaning the application that is sending those messages, right? Very important from the metrics perspective, but also from actual numbers of the messages sent, right? I have seen the cases when the messages were missing, and application had the exact same number of duplicates. So effectively, if you did a count on the messages sent versus processed, um, the numbers would add up, right? But you had a number of messages that were missing and the number of messages that were duplicated, right? So very important, at least from my perspective, to automate and at least to keep track of the service of quality of service. So messages delivered versus messages sent versus messages processed, right? This the in the asynchronous processing, the measurement of that, and especially measurements of the end-to-end latency, becomes a challenge. And often I see people just dropping that, right? So effectively, whatever script they have, whatever tool they use for sending the messages, it becomes effectively a load thrower, right? And what else? What's worse they can do is to just measure everything just on the application side, right? Now, granted, this application processing side is very important, but there is no way you can guarantee the quality of service measurements by only looking into the application, right? And this breaks the first and the most important rule of testing, that the application under test cannot be the test oracle, right? So you should not rely on the application logs or anything like that, on the metrics collected from the application internally. It always has to be assessed from the uh, end user perspective, and this is very tricky and like has a lot of trouble in the past for the users to understand, right? So that's I think since we have covered the sending of the messages, we can also touch on asynchronous flows. So the Kafka applications can actually also serve as asynchronous clients. Um, if you look at the producer records, so okay, the one thing is actually for you to measure the okay back to the sending the messages. Producer record, whatever you send, when you receive the future when it gets resolved. So future is an effectively an asynchronous object that will become materialized after some time. So effectively, in the concept in the context of Kafka messages, the future gets materialized once the message is sent and has met all the criteria for especially for the acknowledgement, and it gets you the record metadata. So this is your best way to measure the um, uh, the best way to measure the latency it takes to for your client for each message, right? You can either get this record, or you can provide the callback. So the message, the some method that you want to invoke after the message has been processed, right? So two ways to measure your latency for each message, right? If you want to do that, right? So send and send. Um, One thing talking about the asynchronicity, I think that's the word. of the Kafka producers is linear and the batch size. So now that we know that the Kafka does not send those immediately, the Kafka producer does not send those messages immediately. Um, there are few options that are relevant to how fast it sends and when does it send the message. This is very important when you, for example, open up the new producer. Sorry, when you open up a new producer and you see some delay that you don't know where it's coming from. So mostly they would originate from linear. So effectively, linear in milliseconds. This is a time where the Kafka producer would wait for a certain period until it meets some certain, or at least it meets some certain size, right? It doesn't send out the messages immediately. It waits for those messages to for more messages to compress them and to send them as one batch, right? So effectively, Kafka producer acts on micro batches instead of as various messages. This is why when you run a load test, you want to make sure you have multiple producers that would simulate your end client's latency, right? If you just use one producer for all your messages, you're going to lose this information and you're going to impose more latency than you want for end-to-end transactions, right? So the retry number of the batch size or the linger, these are the ones that determine how fast the message would spend on the Kafka producer thread before it gets sent to the Kafka broker, right? And these effectively affect your end-to-end latency, right? So the message doesn't get sent immediately unless you specify it to, right? This is very important to remember. It's been I've heard lot of confusion about fighting over a few hundred milliseconds when they exactly matched the configuration of the producers, right? So these are very important to understand. Uh, Something going on here, some activity on other social media. Ah, some likes. That's great. Cool. So there is also the serializer and the key serializer, value serializer. I don't think I've ever seen a other key serializer than the string ones. So, but that's really um, up to the implementation. In here in the properties, you also have to specify the bootstrap servers. Even the thing is, even if you specify a one server, the producer would anyways connect to all the other servers in the from the broker, right? So the Kafka brokers have some ways of signaling when you connect to them. They also have a way for you to signal you all the available addresses. I don't recall the exact name of the property that was, but effectively, when you specify just a single broker, the producer will be aware of other brokers to connect to maintain the resilience. See here, ACKS, this is the number of acknowledgements. So we talked about the resilience and the replication factor. Acknowledgements is the one that waits for the replication, right? If it's set to 1, it only waits for the partition leader, so the first replica or the leader of the replicas for the partitions. If it's set for all, it's going to wait for all the brokers. You can also specify other numbers, but remember, if you want the item potency, so and exactly one's delivery, this have to be set to all. Buffer memory, this is the internal buffer memory. So if there's any latency coming from the broker, the thing is on the network thread of the producer, the messages will be stored there with some buffer, right? So producer will try to resend those messages. There is actually a limit of retries you can specify. in case something bad happens on the producer side, on the broker side, but you can specify the number of retries, and until you have hit the buffer memory limit, you should be fine, right? The producer should recover from any say bad messages, right? And this is why like the asynchronous nature of those producers is what makes them very important to measure the end-to-end latency of your application, right? One say mistake I see people doing whenever they introduce when they try to send new messages from to properties new messages to Kafka is recreating a producer all the time, right? So when you have a load testing tool and you have the action block, so there's an init block, there's an action block. What I've seen people doing many times is they have recreated a new producer every single time they had tried to send a message, right? This defeats the whole purpose of Kafka producers in general, that they were supposed to be asynchronous and they could batch the messages together, right? If you have a single producer for um, for a single message, this defeats the whole purpose of having a Kafka in the first place, right? Normally, you would have a pool of those connections and reuse them every single time, right? It even gets worse when you have a transactional ID. Um, so for the transaction scope, because for like you can only initiate a single transaction. There can be only one producer opened with the same transactional ID, right? So I think the Confluence recommendation is to have one transactional ID per topic per partition, and have one producer per it, right? So, and this because like underneath they have some storage of those transactional IDs. They store it only in memory, so you can actually, if you recreate too many producers with the same transaction ID, you can actually kill the transacted threads of your Kafka brokers, right? Very important stuff, and also remember to reuse those producers um, anytime you want, anytime you can, right? If the application like is doing that, if you want to replicate your behavior and your application actually just sends a message every few minutes, then it is feasible to recreate the topics. But if you have a high throughput load on the Kafka side, remember to keep track of the producers and make sure that they are reusable, right? So very important stuff. Something that people tend to miss when they design the load test. Sister, second, is going to. I was going to also talk about some other stuff. Okay. Um, okay, so that's for the producer. I think. I think we can stop for today. I really want to save the best pieces for later, that we have, more people. I understand that having a stream on Sunday noon is not a best idea, but this is also one of the time slots I had um, to just to record anything. Okay, and I was also wondering how the whole drawing would work. Actually, I'm pretty proud of it. what I did here. Not sure how it's gonna look on the stream though. I have some overview, but not sure how this draw IO images would look on the stream. Pretty good, I guess. Okay. I think we can conclude on this. Like, think we can stop for now. I don't see any messages in chat. I have to just stir. Okay, so batching, we've covered that. We've covered the synchronicity of these. We've covered the replication. We've covered the consumer groups, producers. We've covered the partitioning strategy, replication, brokers. I think that's most of it. Let me just briefly check the chat. See, I'm still learning this whole streaming things. It's all new to me. I'm hoping I don't get anything wrong. This whole new setup is also quite new to me. Okay, see, I'm not even prepared. I'm not even looking at the right place. Should be looking at my videos. Should open the chat. You guys have any? Oh, there is nothing in chat, of course. I have this number here. Okay, guys. So I think we can stop here. I'm gonna prepare some new session maybe on getting things started with Gatling, and I think that's a good introduction. So thank you if you have been watching this. Thank you very much, and have a nice rest of the day.